Alright, what we're going to be looking at now is in section 7.7. We're looking at inverse functions, and we're looking at how we can use them to solve different things and kind of what their graph looks like. But we're focusing on inverse functions and inverse relations. So the first thing is, what is an inverse relation? And an inverse relation is basically if you're given a function and you find its domain and range, okay, at any point. So if you say the domain at 4 is 7, or when the domain is 4, the range is 7. The inverse of that takes those points, okay, so if we say 4, 7, if that's your original, it takes those points and it switches them. It says, well, the inverse of it, if it's at 7, it's 4. Okay, we switch the domain and range of our function. And basically for us, the way to find it is that we take our original function, we switch the x and y, like what we did down here, switch the x and y, and then solve. So if you had y is equal to 9x plus 4, okay, and you want to find the inverse function, what you're going to do is that you're going to switch the x and the y. So you'll have x is equal to 9y plus 4. Minus 4, minus 4. X minus 4 is equal to 9y, which means y must be x minus 4 all over x minus 4 all over 9. So all we're doing is that we're just switching them, and that's all it is. Okay, and that's your inverse function. All right, this is what a graph looks like of an original function, which is this one up here, this parabola. Okay, and then its inverse. Okay, so this kind of the parabola pushed over is its inverse. Okay, and what happens is that we have a reflection, and the reflection is based around this line. This line is always y equals x. And so what we have is that if you were to take any point on this parabola, so let's say this point at about 2, which is at about 2 comma 4, its inverse, if you were to go straight across, would be at, or the point that's related to it would be at 4 comma 2. And as you see, we've switched the x and the y. Okay. Now if you look over here at we're at negative 1, 1. Okay. The inverse of this one would be right about there, which is at 1, negative 1. Okay. So as you see, it's the same distance away from each other for a given point. It's the same distance from that x equals y line. Okay. And so all inverse functions will always have this reflection around this line, y equals x. Okay. Alright, so our inverse function. So find the inverse of each of these. And when you denote inverse, inverse is f to the negative 1 of f of x. Okay. That's how we usually write our inverses. So here, this first one, we'll have y is equal to 3x plus 8. Take the inverse, so it'd be 3y plus 8 is equal to x. Move the 8 to the other side, 8 minus x all over 3 is equal to y. Okay. So again, all you're doing is you're just switching your x and y values and then solving. So y equals x cubed plus 9, subtract 9, getting you, switch these. So we have x is equal to y cubed plus 9, subtract 9, getting you an x, minus 9 is equal to y cubed. Get rid of the cube. We take the cube root of both sides, which gets you that. And now the last one we have y is equal to the square root of 4x plus 8. Switch the x and y. X is equal to the square root of 4y plus 8. How do we get rid of the square root? We square both sides. X squared is equal to 4y plus 8. Okay. Move the 8 to the other side, subtract 8. X squared minus 8 is equal to 4y. Divide by 4, getting us our y is equal to x squared minus 8 all over 4. And that is our last one. Okay. So see, finding your inverse functions are pretty simple, pretty straightforward. All you got to do is you switch the x and y and then solve for the y again. Okay. Okay. Now, where would we use inverse functions? Inverse functions are very nice whenever you're given any type of formulas. Because what a formula usually does is it has multiple variables in it. And what an inverse can do is go, okay, if you want to find the speed of something, but the speed is in the formula that finds distance, well, we can take the inverse if we know what the distance is, and we're able to solve it. So here, this is an example of using temperature. So everywhere else in the world except in the US, most countries use Celsius to name off how warm it is outside. And science, they use Celsius or they use Kelvin. Either one of those. So the temperature to convert from Celsius or from Fahrenheit to Celsius is C is equal to 5/9 times F minus 32. Eugenia Brenna is playing baseball in Venezuela, and it's hot outside. He looks at the temperature and he sees that it's 40 degrees. And so what Eugenia is thinking to himself, well, he's been playing baseball for a while, and he doesn't know exactly like how warm that is in Fahrenheit, like what he's used to be playing in. And so we want to help him solve it. So what we're going to do here is that we're going to be using the inverse. We know what the Celsius is, but we want to find F. So what we're going to do is that we're going to solve for F. So first thing we have to do is multiply by 9/5. So that gives us 9 over 5 C. And then we're going to add 32 plus 32. And that equals Fahrenheit. And that is our inverse. See, the inverse helps us with solving the equations that we have. Okay. And now all we have to do is we just take 40 and we plug it in for our C. And then we're able to figure out that it's about 104 degrees Fahrenheit. So it's about 104 degrees Fahrenheit right now when he's playing baseball down in Venezuela. Okay. So that's one of the important things that an inverse can do. Now, your IRAT. What you're going to do here is you're going to find the inverse of these three functions. Okay, make sure you keep it in your answer should be in the y to the negative 1 is equal to, or f to the negative 1 equal to, or y equals. So once you switch it, solve for y. Solve for the variable. Okay, for all three of these. Okay.